Hello everyone, here is Mr. Bistawi. In this short video, I'm going to solve some problems about the mole conversions. Let's get started. First thing, before solving problems about the mole, we have to know that we have two main conversions for the mole. From mole to mass, and it will be using the molar mass. So we need to use the periodic table to find the molar mass if we would like to move from mole to molar mass in grams. The next conversion is from mole to number of particles. What we are going to use, we will use Avogadro's number. So 1 mole is equivalent to Avogadro's number, which is 6.02 multiplied by 10 to the power 23 particles. Let's check our examples here. The first example is work out the mass of one molecule of H2O. Okay, so what we have in the problem is one molecule. So we have number of particles. And we would like to find the mass, but we cannot go directly from number of particles to molar mass. So we'll go to the moles first, then from the moles to the molar mass, or the mass that we want to calculate. First thing, we would like to, we have to write the ratio or our reference. Our reference is 1 mole of any substance. So 1 mole of water, 1 mole of water is equivalent to Avogadro's number, which is 6.02 multiplied by 10 to the power 23 H2O molecules. Okay, so what if we have one molecule H2O? How many moles, or what is the equivalent amount in moles for one H2O molecule? We'll just do cross multiply, and so it will be 1. So it will be 1 multiplied by 1 over Avogadro's number. This is the cross multiply that we should do. So the answer, the amount of moles of H2O, which is equivalent to 1 water molecule, is 1.66 multiplied by 10 to the power negative 24 mole. Okay, now we have the number of moles. Can we find the mass? It is easy. What's our reference? 1 mole of H2O is equivalent to the molar mass, which is 18.02. How did I calculate the 18.02? We can calculate it from the periodic table. As we said before in the previous video, we have hydrogen, which is 1.01. Its molar mass is 1.01, and we have 2 hydrogens plus 1 oxygen, and the oxygen mass is 16, so we will have 18.02 grams. Okay, so now if we have this amount, 1.66 multiplied by 10 to the power 24 moles of H2O, what is the equivalent amount in mass? We'll do cross multiply again, and it will be 2.99 multiplied by 10 to the power 23 grams. This is the mass of H2O, which is equivalent to or the mass of one molecule of H2O. Okay, the next problem, let's check this out. Work out the total number. So we need to calculate the total number of hydrogen atoms in 1 mole H2. Okay, so now we have 1 mole H2, 1 mole H2. How many hydrogen atoms? Okay, you know, it's simple but a bit tricky. H2 is an atom or molecule? It is a molecule. So how many hydrogen atoms here in this molecule? Okay, we have only 2 hydrogen atoms. So we need to put that in our consideration when we are solving this problem. H2 molecule has 2 atoms hydrogen. For that reason, 1 mole H2 has 2 multiplied by Avogadro's number atoms. Why again? Because H2 is a molecule, it has 2 hydrogen atoms. So to remove the mole, we need to multiply by 2. And we need to remove the mole, we need to use Avogadro's constant. And to find out the number of atoms from a molecule, we just count how many atoms we have. So 2 by Avogadro's number, and if you put that in the calculator, you will get this number. Let's check another problem. Calculate the total number of atoms. Total number of atoms. So we'd like to find the total number of atoms in this mole of ammonia. Where is our reference? Here is our reference. 1 mole NH3. 1 mole NH3. How many atoms there? We have 4 atoms. Originally we have 4 atoms. Why we have 4 atoms? Because we have 1 hydrogen atom and 1 nitrogen atom and 3 hydrogen atoms. So we have 4 atoms multiplied by Avogadro's number. Then if we have 0.01 mole NH3, how many atoms we should have? So we'll cross multiply and we'll find that the total number of atoms is equal to 2.41 multiplied by 10 to the power 22. This is the total number of atoms in 0.01 mole NH3. Let's check another example. Calculate the number of moles of oxygen atoms in 0.2 mole H2SO4. Here there is a tricky part. What's the tricky part? It's asking about the total number of moles. Okay, so we will not use Avogadro's constant here. We were using Avogadro's constant in the previous problems because we were asked to calculate the total number of atoms. But if we would like to calculate the number of moles, okay, so we just count without considering Avogadro's number. Let's check it out. 1 mole H2SO4, how many oxygen atoms? 4 moles of oxygen atoms. If we were not asked about how many moles, so if this was not here, we would replace it with Avogadro's constant. So we would say 4 by Avogadro's constant will give us this amount of oxygen atoms. But because they are asking about the number of moles, it is we have 4 moles of oxygen atoms. If we have 0.2 mole H2SO4, we will do cross multiply, and we will, so 0.2 multiplied by 4 over 1, then we will have 0.2 moles of oxygen existing in 0.2 moles H2SO4. Hope it's clear, and see you in the next video.